Welcome back students. So today in this video we are going to learn about the topic Newton's law of viscosity, and as we have discussed in our previous video, viscosity is defined as the internal resistive property of fluid offering resistance to the movement of one layer of fluid to another adjacent layer of fluid. Okay, so viscosity is the property of real fluid, which is the internal resistive property offering resistance to the movement of one layer of fluid over the another adjacent layer of fluid. To understand this, let us consider a solid boundary and let us consider a section over it. Now along this section, let us consider the velocity u, varying velocity u in the direction of x with a distance y in the direction of y. So here small u is velocity which is varying in x direction, okay, and y is the distance which is varying in y direction. So when this viscosity will happen between two layers of fluid, it will, along with the change in relative velocity, it will induce shear stresses between the two adjacent layers. Let us understand it. So if this is a section, so at this point my velocity will be 0. The velocity of the fluid will be 0, but as it will move away the surface of the boundary, the velocity will keep on increasing. Okay, so it will be like this. So let us here I am assuming two layer of fluid. So this is the first layer of fluid with velocity u, and this is the another layer of fluid with a velocity of u plus du. Okay, so this is one layer of fluid whose velocity is u. This is another layer of fluid whose velocity is u plus du, which is changing with respect to direction y, and that change is represented by dy. Okay, so as I told you that along with the viscosity, along with the relative velocity and viscosity, shear stress will be induced between these two layers. So this layer will induce shear stress on this top layer, and this adjacent top layer will induce on adjacent bottom layer with velocity u. So I can write that shear stress is directly proportional to velocity gradient. So shear stress is represented by a symbol tau, while velocity gradient is nothing but rate of change of velocity in x direction with rate of change of distance in y direction. Okay, so du is the velocity which is changing in x direction with respect to a distance which is changing in y direction. So this is shear stress which is proportional to velocity gradient. This is also known as rate of shear deformation. Okay, and if I will remove this constant of proportionality or proportionality constant, then I will get tau is equals to mu du by dy, where mu is known as coefficient of dynamic viscosity whose unit is Newton second per meter square or poise, and 1 Newton second per meter square is 10 poise. Okay, so this you need to remember, and this is known as Newton's law of viscosity. Now the fluids that will obey this Newton's law of viscosity are known as Newtonian fluids. Okay. So the Newtonian fluids are those fluids which obeys Newton's law of viscosity, and non-Newtonian fluids are those fluids which doesn't obey Newton's law of viscosity. So here the equation tau equals to mu du by dy is known as Newton's law of viscosity, where tau is the shear stress, mu is the coefficient of dynamic viscosity, and du by dy is known as the velocity gradient or rate of shear deformation, where du is the rate of change of velocity in x direction and dy is the rate of change of distance in y direction. Thank you.